evaluate the integral from 0 to the power over 4 cosine cubed on twice x times sine squared on twice x. We isolate the power that's odd. In this case, it's the cosine of twice x that's cubed. And we factor out one of those, cosine of twice x. So we'll have the cosine squared of twice x times the cosine of twice x. We still have the sine squared on twice x. And so the reason we'd like to do that is so that we can set up a u substitution. So we're going to take this cosine squared and make it right next to the dx. And then, take the cosine of twice x, put it right next to the dx. For the cosine squared, we're going to change this into sine squared. And so, let's use different colors here. We're going to have the integral from 0 to the power over 4. Alright, so we're going to have 1 minus the sine squared on twice x and that all comes from the cosine squared. Then we have the sine squared on twice x. That comes from the original problem. And then we're going to have the cosine of twice x dx. And the purpose is to set up a u substitution so that what's in blue here, the cosine of twice x that you peeled off, becomes part of du. If u is the cosine of twice x, if let u be the sine of twice x, if we let u be the sine of twice x, then du is twice the cosine of twice x. Dx. Oh man, I'm running out of room. Twice the cosine of twice x dx. And so half of du is going to take the place of the blue there, cosine of twice x dx. These guys become 1 minus u squared times u squared, and then we have half of du. So that's what that integral becomes. We'll deal with the limits of integration when we switch back. If you like, we could change the limits of integration. When x is 0, the lower limit, then u, plugging into the substitution, is also 0. When x is pi over 4, then u is the sine of pi over 2, which is 1. So if you like, we can do that, where we have new limits of integration, 0 and 1. Alright, almost done. Let's pull out the half. And let's distribute the u squared across. U squared minus u fourth du. And that's from 0 to 1. So we're going to have u cubed over 3 minus u fifth over 5 evaluated from 0 to 1. And that works out nicely that we switched limits. The upper limit is a third minus a fifth, and conveniently the lower limit is 0. And so common denominator is 15, and so we get 5 minus 3 of those 15s, and that whole thing is times a half. For the final answer, this is a 2, so half of twice, a half of 2 over 15, and the answer is 1 over 15. Whatever, if it was area, the whatever unit we have squared. Okay, so the key is to isolate the power that is odd and peel off one of them to become part of du when you do a u substitution. Very good.